Hey there, welcome. My name is Ryan Hayes, and I'm a developer with the AWS Solutions team. Today, I'm going to be introducing you to AWS Solutions Constructs and showing how you can use it with the AWS CDK to make building applications simpler. So let's go ahead and get started. Oftentimes, when building an application, we find ourselves re-implementing the wheel when it comes to modeling the infrastructure. Let's take a simple example, a Lambda function that can read and write data to a DynamoDB table. It's a very common architectural pattern, but each time we want to build this in, we have to invest cycles into individually defining and configuring each service, as well as wiring it up and ensuring alignment with established best practices. This exposes some repetitive steps in our workflow and can even draw valuable development time away from implementing the unique features of our application. The AWS Cloud Development Kit, or CDK, helps us cut through a lot of this repetition by enabling us to model and provision our cloud resources programmatically. It provides a library of high-level components that pre-configure cloud resources through AWS CloudFormation. This is while using the expressive power of programming languages to reduce manual actions, custom scripting, and template maintenance. The CDK also brings a significant boost to testing and QA for our infrastructure, since it allows us to write test cases and define expected behavior for our cloud resources. But one key thing to keep in mind here is that individual CDK constructs are largely focused on a single service, meaning that we still have an opportunity to close the gap even more when it comes to being able to model common architectural patterns. This is where AWS Solutions Constructs come in. AWS Solutions Constructs is a library of higher level constructs that wrap together two or more CDK constructs to create multi-service architecture patterns. Each pattern is fully customizable, but also comes pre-configured with best practice defaults to help reduce repetitive configuration steps upfront. The patterns also work seamlessly alongside CDK constructs, so you can leverage the power of both libraries to get to exactly where you need to be. Let's take a closer look at how we can fundamentally think of an AWS Solutions Construct. In our library, similar to the use case we discussed earlier, we have a pattern called AWS Lambda to DynamoDB, and it encompasses the following things. First, it has a CDK construct for a Lambda function, a CDK construct for a DynamoDB table, and then any necessary permissions and configuration for the Lambda function to be able to read and/or write to the table. And finally, it comes with a set of best practice defaults for you to be able to use it out of the box if desired. What this enables you to do is simply import and declare this architecture pattern once within your project, and all of those components will be staged for you without having to do it in individual separate steps. So now that we have an idea of what's under the hood of an AWS Solutions Construct on the conceptual level, let's take a look at how we can build a real solution using them. Today, we'll be taking a look at the Amazon Virtual And-On solution, which is an existing solution within the AWS Solutions Implementations portfolio. This solution provides a scalable system for monitoring manufacturing workstations for a particular event, such as a defect or error. If one of these events is detected by the solution, it then logs the event and routes it to the appropriate engineer for resolution in real time. The architecture for this solution consists of roughly 10 AWS services or resources, and we're going to take a look at how we can assemble it faster and in less steps using AWS Solutions Constructs. So working through the diagram, we can see a few common pairings of services already. We see that first, we can use the AWS CloudFront S3 pattern to cover building out the infrastructure needed to support our web console. Next, we can use the AWS IoT Lambda pattern to flesh out our data ingestion capabilities, which will be used to receive data from devices in the manufacturing environment and route qualifying events through to the Lambda function. Third, we can use the AWS Lambda SNS pattern to extend our Lambda function and give it the ability to send a notification to our factory engineers when an anomaly or qualifying event occurs in the process. What we could start to see here is a notable amount of busy work being abstracted away from declaring each of these pieces individually and wiring them up. As a result, this fast tracks us on to building the unique, tangible features of our application. From this point, we can then use constructs from the CDK library to build out the remaining parts of our application to support things like authentication and APIs. So without further ado, let's dive into a real-world demo of how we can get set up and start building this solution using AWS Solutions Constructs. For today's demo, I'll be using TypeScript as my language of choice, and I'll be using AWS Cloud 9 as my development environment. For those in the audience who prefer to use a different development environment, all you'll need to follow along with is to have your favorite text editor handy and have the latest version of Node.js installed. So diving into our demo, first things first, we'll need to install the AWS CDK. This will provide us with the command line tools that we'll need to build, test, and deploy our work. To bring it in, we'll do a global install using npm install with the G flag for global, and then AWS-CDK. This can take a couple moments to complete depending on your internet connection. Now that we have the CDK installed, we can start creating our project. We'll first create a new folder and give it a name. Then we'll change directory into that project folder. Now that we're at the root level of our project, the next step is to initialize it. For this, we'll run the CDK init command specifying the language of our app as TypeScript. This will create an empty bootstrapped CDK app for us to start building with. It may take a few minutes to complete as it downloads, installs, and stages the baseline artifacts in your local development environment. Now that we have the all clear from our CDK init command, let's expand our project structure here, and I'll touch on a few important things to note. Working downwards in the sidebar, you can see a bin folder. This is where our CDK app will reside. Next, under the lib folder is where our CDK stack will reside. This file is where we'll be doing the majority of our work today. Underneath the test folder is where we can start to flesh out test cases for our architecture. And finally, the last thing we'll be working with today is our package.json file. One important item we'll have to take care of before diving in is to make sure that all of our AWS Solutions Constructs and AWS CDK dependency versions are the same. So what I'm going to do here is just adjust my CDK dependency versions to match the most recent Solutions Constructs release. Then I'll go ahead and save the file and rerun npm install to bring in all the right versions. Now that we're all matched up, let's see what happens when we build and synthesize our empty project. First, I'll run the npm run build command to build my project from TypeScript into JavaScript. As the command executes, you'll see some additional files created in your project structure as a result of running this command for the first time. Next, I'll run CDK synth to show the output of my currently empty project in CloudFormation. As you can see here, we have a little bit of output in the terminal. But then when we go over to the actual template under the cdk.out folder, we can see it's completely empty. This is a good indicator of everything being set up correctly before we dive into building our solution. Now let's jump over to our architecture diagram. Here we can see the 3 solutions constructs we'll be building with today, as well as the other 4 services we can continue on to cover using regular AWS CDK constructs. Now that we have an idea of what we'll be adding in today, let's go over to our stack.ts file under the lib folder and start adding in some comments to delineate our steps. First off, we'll add a section for our web console. Then we'll add a section for our data ingestion engine. Third, we'll add one for our notification service. And lastly, we'll add a stub out for the remaining services that we can integrate using regular CDK constructs, which we won't cover in today's demo simply for time. So now it's time to start modeling the infrastructure for the web console. As you can see with the architecture diagram, we'll be using the AWS CloudFront S3 pattern from the AWS Solutions Constructs library to implement this. Switching tabs to our doc site, let's find the AWS CloudFront S3 page, and we'll have a look at the full description of what the pattern we'll be using is, as well as the details pertaining to where you can import it from, what you can use it with, how you can use it, any parameters and defaults, and finally an architecture diagram at the very bottom. Since we're using TypeScript for this demo, we'll go ahead and take note of the package name so that we can install it from npm. Back in our development environment, we'll now install the package from npm. Note how we specify the version number to continue to avoid mismatches. This can also be done in the package.json file. Great, now that our installation is completed, we can now import the package into our stack file by adding an import statement at the top. Next, we'll go ahead and define the pattern in our code and check for any errors present in the IDE. With the all clear, let's go ahead and run npm run build to build the local changes that we have. Finally, let's run CDK simp to synthesize the template and have a look at our solution now. Great, so it looks like we have some new output to the console. Let's take a look through, and then we'll jump over to our template file. As you can see here, we have a much more populated file than before. And this really highlights the power that we have here to produce a significant amount of lines worth of code in very little actual lines of code. Here's a quick look at our current stack using the AWS CloudFormation Designer. Now, let's go ahead and break ground on our second piece of the puzzle, the data ingestion engine. For this part, we'll be using the AWS IoT Lambda pattern from the AWS Solutions Constructs library. Same process as before. Let's go ahead and refer back to our documentation, finding the page for AWS IoT to Lambda, and we'll take a look at the package name as well as the minimal deployable pattern to get an idea for the required properties. Heading back to our solution stack, just do a little bit of tab cleanup real quick to keep things tidy. And now looking down at the terminal, we're going to run two commands for this pattern. First, we'll install the pattern itself from npm, using that same version number throughout. Great. Next up, we'll install the Lambda construct from the CDK library so that we can set required properties like where to source the Lambda code from and what runtime we'd like to use. Now that our installation is wrapped up, let's go up to the top of the stack file and add in some import statements, one for the pattern and one for the Lambda CDK construct. Next, we'll go ahead and stub out our properties object and start defining our pattern. Taking a look at that red X, we notice that there's a few properties missing that were expected. This means that we'll have some required properties to fill in, which we'll do in just a moment. So now working back, we'll add properties in for both the Lambda function and the IoT topic, and we'll do some configuration on them to match today's use case. Now, one important thing to note here is that we'll need to provide the source code that will be attached to the Lambda function in this pattern. So using the file path that we see here, we'll add a folder structure under the lib folder for our Lambda code to reside. We'll create an empty index.js file, and then we'll paste in some sample code for our Lambda function to use for now. We're doing this under the assumption that real business logic would eventually be implemented at some point down the road. So now that everything looks good, let's circle back to our console and we'll run npm run build one more time to build out our local changes. Next, we'll run CDK synth to have a look at our project now. As you can see here, our template file is now even larger. And scrolling down towards the bottom, we can start to see some resources pertinent to our IoT pattern. Now looking over under the CDK out directory, we now have an asset folder which our Lambda source code sample has been copied over and staged in. Here's a quick look at our current stack using the AWS Cloud Formation Designer. The stars denote new services added from our previous glimpse here, which we could see that 5 new resources have been added to our solution. Moving right along, let's break into the third and final piece of our puzzle using AWS Solutions Constructs, the notification service. So coming right back to our architecture diagram, we've already implemented our web console using AWS CloudFront S3, our data engine using AWS IoT Lambda. Now it's time to implement our notification service using AWS Lambda to SNS. Before we jump in, let's have a look at the documentation. We'll scroll down a bit and open our AWS Lambda to SNS page, and we'll make note of the package and any required fields needed. Next, we'll head back to our development environment and open up our stack file. Using the command line, we'll install our AWS Lambda to SNS pattern from npm. Now that the installation's finished, let's move up to the top of the stack file once more and add in our import statement. Great. Moving down the file, we'll start stubbing out our props block. Now that our props block is stubbed out, we can then go ahead and define our pattern right underneath. Now we'll add required properties into the props block, which in this case is what we should be using for the Lambda function. For this pattern, we'll be referencing the Lambda function from step 2, which is our AWS IoT Lambda stack. So we'll have an existing Lambda object field and pass that Lambda function in there so it can all be linked up. Taking a look through the stack file, everything looks good. So let's go ahead and run npm run build to build our local changes. Next, let's run CDK synth to have a look at the current state of our project given the addition of the third pattern. As we can see, we got some successful console output. Let's have a look at our template under the CDK out directory. Great, so as you can see here, we have even more lines of code than we did before, with particular attention to the SNS permissions you see here. Here's a look at our finalized stack using the AWS Cloud Formation Designer. The stars denote new services added from our previous glimpse in step 2, and we can see that 2 new resources have been added to our solution. This is now the full infrastructure model that we were able to build using just 3 AWS Solutions Constructs, and it amounts to 880 lines of CloudFormation code created by just 42 lines of TypeScript code. So to recap what we saw in the demo today, we took a look at how we can divide our architecture up into commonly used patterns and then use AWS Solutions Constructs to cut out the repetitive steps in implementing them. We then set up a sample development environment and started using patterns to build our solution. We used an AWS CloudFront S3 pattern to model out our web console, which will be used for managing events within the manufacturing space. We used an AWS IoT Lambda pattern to build our data ingestion and processing capabilities, used for ingesting events from devices and properly routing them. Finally, we used an AWS Lambda SNS pattern to add notification capabilities to our system so that we can alert factory workers if something were to go wrong. We finished the demo in a place where we could pick up right where we left off and build in some regular CDK constructs in the very same stack file to cover things like authentication, APIs, and other features we might want down the road. Now, let's take a closer look at the documentation and references that come with each pattern in the library to help us build. Each pattern in the library ships with a full suite of documentation to make it easier for us to start building with it and to also let us tailor it to the unique needs of our application. This provides information on where we can install the pattern from, how can we start using it right away, which properties we can customize, which underlying resources we can access to do things like linking multiple patterns together, a full summary on the pre-configured best practice defaults, and finally an architecture diagram to see exactly what we're getting from the pattern. Now that we have all the bases covered for building using AWS Solutions Constructs, let's talk a little bit about testing. There are 3 types of test cases we can employ to help ensure our architecture is modeled and provisioned as expected. The first is unit tests. These are resource and property level assertions that can be written to test the configuration of individual components using familiar test suites such as Jest. Second, we have snapshot tests. These are point-in-time captures of your stack that allow for comparisons when changes are made over time. If an update is made and it affects our previous configuration, you'll be made aware of it to reduce the risk of unintentional changes. Third, we have integration tests. These provide end-to-end deployment validation for different deployment scenarios. An example of this is testing the expected output of an off-the-shelf pattern versus one that has been customized. Together, these testing strategies enable us to ensure our architecture is consistently modeled and deploying as expected. They also help prevent unintentional changes to our architecture and increase maintainability by formalizing QA in our infrastructure. This in turn yields a significant opportunity when coming from template-based modeling. After developing our testing strategy, it's time to start thinking about deployment and publishing. There are a number of different ways to deploy projects from within our local development environment into use, with each depending considerably of the target user, usage characteristics, and other variables. These are just a few approaches to deployment that we can consider when preparing to roll out our infrastructure. First is deploying directly into the cloud from our IDE. This can be done simply by running the CDK deploy command, which will synthesize and deploy our stack into our account using AWS CloudFormation. Second is synthesizing our project into a CloudFormation package, consisting of one or more templates and one or more source code artifacts. This can be done using CDK synth command and is useful for groups that might still be invested in template-based modeling. Finally, we can leverage CDK pipelines for a full CI/CD integration, which offers the most flexibility in terms of managing deployment stages and the overall lifecycle of our solution. Now that we've taken the development lifecycle from end to end, let's wrap up with a look at some of the key benefits from building with AWS Solutions Constructs. So why should I be using AWS Solutions Constructs and the AWS CDK when building my applications? To start, delivery is often accelerated due to the reduction of repetitive or manual steps, allowing more time for building the unique features of your application and getting it delivered sooner. You can build with confidence knowing that your infrastructure will be well architected and will adhere to AWS best practices right out of the box. You can also use and reuse components of your application, making it easy to extend infrastructure and avoid re-implementing the wheel across projects. And finally, it's easier to maintain your application. There's a significantly lower amount of code to read through, and with leaps forward in terms of automated testing and QA, your application becomes all the more bolstered. So that wraps up our discussion and demo today on what's new with AWS Solutions Constructs. Thank you for tuning in today, and I look forward to answering any questions you might have. For more information, please visit aws.amazon.com/solutions/constructs. My name's Ryan Hayes, and I'll see you next time.